So SIFT. SIFT, what is SIFT first? That you have to. So what is the full form of the SIFT? So that things first you have to know. After that, we have further process step by step how these SIFT techniques have been used to find the features of an image data. Okay. So the full name of the SIFT is the scale invariant features transformation. The full name is scale invariant features transformation. Now let's see how these things are actually work. I think all of you have known about the OpenCV in Python language. OpenCV, this library actually internally they have used this technique to find the object of an image. OpenCV in Python language. They have internally used this technique to find the some object. So the the key points, the applications of this technique, SIP technique is mainly object to find some objects in an image. Find to find the objects in an image. Okay. Now the second applications, it's also it is useful to find the searching image search. Sorry. For image search, it is also applicable. Suppose let's do an example. Suppose I am going to some Google web page, and I think all of you know about the Google image search. Okay, just they want to browse some image on their applications, and on the basis of that image, they will give some output corresponding. How the things they have doing. Suppose I am talking about this Google image. Suppose there have the Google databases. This is the databases of of the images in Google server. In some server, okay, there have some images. There have lots of there have lots of nature image. There have lots of books image. Like there have various type of various type of image. First, what I am doing here, we have a image. Suppose it's our query image. We have some image. We call the query image. This is our some image. Means query image. There have we have, and we have to based on this query image. We have to search some image from our databases. That's the thing that we have to do. Sure. So suppose let's there have some query image, image query image. We have to give something. So this the thing. For searching the image, searching some kind of image, that's the things that actually help us by by example using the open survey. That's the technique. So let's see step by step how these things are actually open. I think it will be better if we take through an example. Okay, so let's try to understand through an example. Suppose this is the image that I have taken from the OpenCV website. If you search it, the OpenCV site, then you can easily find this picture. Or you can simple search it on Google. You can also easily find this picture. So the first thing that we have to do here, we have to find the key points for each. Just say it for the each points of the each pixels of this part. So suppose this is some pixel, different color. This is some pixels on this picture. This is somewhere some pixels. There have 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 some pixels. First thing that we have to find the key points for each pixels. So first we have to find the key points. Key points for each pixels. How we will find this key points value? In general, we have seen that this key point value is in the 28 dimension. Okay, 28 dimension. This key point value is 20 dimensional and it's a vector. This value is in vector form. 128 dimensional vector form. Look like this type of vector. Its dimension is from 1 to 128. Okay, for each pixels we have to find the key points value. Okay, for each pixel, that is the suppose that the image already have in Google. Okay, Google has internally built at Google. Suppose I am taking the examples Google. Actually, they have some this kind of collections of some huge amount of image. First thing, they have built an algorithm that will find the key points of the each pixel for each images. Okay, the technique are actually doing this job. So from the image databases, these are the image databases. This picture is from the image databases. So internally, like Google's or Amazon's or like Facebook, they have some huge collections of image, and they have first find the key points of each pixels of each point. Okay, first. So that's the first thing that I have to do. Now, based on these key points, say have to find the suppose it's our query image. Suppose let this image our query image. This is our query image. Now on this query image, we have seen here have some pictures, here have some pictures, here have some pictures, there have some blank area like that. The first thing that do the Google's image, already from the image databases, they have calculated the key points value. Now from our query image, they have calculated the key points from the edge density like that. Like they have find here, they have calculated some key points from here, from here, from here, from here, here. Look like this, and they find that after calculating the key points value of that query image, they find that from this key points value that match accurately. From this key points value and this key points value are the match accurately. Then they gives us this will be the our related image to that. That's the simple thing. The machine learning, big huge billions-dollar company are used this simple technique. Just they have collected the image databases, they have built their image databases, and they have find the key points for each pixels. Based on this key point value and based on the key points of a query image value, they will give the some output onto it. Okay, suppose let's see. Here they have some images on this query point. Here I have detected. Here I have some images. Here I have some images. Like that. So from the each one, it is since we have already built SIFT technique that doing the internally find the key points for the edge pixels. SIFT is also find the key point from here from edge pixels of these images, and they will try to match this. What will be the same similar kind of key points value? Based on this, he will the algorithm so gives the output. Okay, that's the internal job. Okay, I think you all got the point. So the another thing is that here the SIFT, if you just see this name, scale invariant, internally call this technique as scale invariant. Scale invariant means it's totally scale size of the image. It does not matter. Here in our databases, this type of huge amount of images we have, but in our query image, size is that this is rotational, rotate something like that. Its shape is different. Okay, it's different from angles like that. So these things actual totally depends not on the size, what kind of rotation they have, just it's based on the key point value. It gives us the output. Okay, because of this reason, we call this technique as a scale invariant. All this is a scale invariant. Scale invariant. Since it does not matter what kind of scale invariance as well as the rotational invariant. Scale as well as it is a rotational invariant. Okay, I think you got the point. How these things are invariant, scale invariant. It does not matter what size it is big. It does not matter. It is small, large, medium. Okay, it's not dependent on the rotations. How much rotate it will be, stretching or in this angle, like this type of rotational invariant. Okay, this is the simple technique they have used. First, they have built the. I'm not going to discuss the how these internally shaped algorithms are actually work. I'm just giving the intuitions how this shift algorithm actually helps us to detect some features of an image. So the shift in scale invariant, they have some our databases, they have some standard images. Based on the standard images, we have built the key points value. Now from our query images, from our query images, applying the shift algorithms, we will build the key point, we will find the key point and try to match what key what key points value at the similar type. Corresponding to that similar key point value will give the output. The sample thing. It does not matter how much scale it is, how much size of the image, how much rotational, how much angle they are. It does not matter. Just it is matches the key point. That's the thing. I think you got that. Okay, how this the SIP technique are actually work. When we will discuss the case study, then there are very many minute case studies. We will apply this SIP technique onto it. So then I think it will be better for better understanding. Okay, when we will discuss the case study and applying the SIP technique by using this OpenSAVI library, then it will be better for you for better understand.